copy down your target. We're going to focus on squares, square roots, and finding the square roots. So hopefully at the end of this lesson you'll be able to find and evaluate expressions involving square roots, as well as determine the two integers that a square root is between, and even estimate the value of that square root. So copy down the target and complete your warm-up. Pause the video to do this, and then press play whenever you're ready to go over the warm-up. Okay, so you have your target and your warm-up completed. The warm-up, I gave you 3 warm-up problems. Take a look at your work, and if you have any corrections to make, go ahead and do that at this time. You should know that squared means you're taking that base and multiplying it by itself 2 times, or however many times the exponent says. So you get 36 for A. For B, that you may have made a mistake on this one, so pay attention and make sure that you did get negative 64. If you didn't get negative 64, it might be the negative that was throwing you off. If there's no parentheses, the exponent only goes to the base that was directly in front of it. So this problem, expanded out, would be negative 4 times itself 3 times. But this problem that I gave you in the warm-up, since the negative is just out front, it would be like a negative 1 times that base. You actually would end up getting the same answer, negative 64, but you should know the difference between there being parentheses and not being parentheses. And the last warm-up, I did it 2 ways. You could do order of operations and add what's on the inside first and then multiply. You could also use the distributive property. It doesn't matter which way you do it, although the order of operations is a little shorter in your work. Both get you 60. So finding the square root, a perfect square is a number that has integers as its square roots. If it has integers as its square roots, then the number is a perfect square. One of the smaller perfect squares that we know is 4. 4, when you square root it, has 2 integers as its square roots, 2 and negative 2. The principal square root then is just the positive root. So find the square root of each number, and then which one is the principal root. Go ahead and try these 4. You can pause if you want to do it ahead of me and then press play. You should be able to do these pretty quickly. Number 4 may hold you up a little bit. So for number 1, the square root of 64, we're going to get 2 roots. What times itself gives me 64? It would be 8 times 8, or negative 8 times negative 8. So 8 and negative 8 are the square roots of 64. The square root of 1. 1 is a perfect square. 1 times 1 gives me 1, and negative 1 times negative 1 gives me 1. So 1 and negative 1 are the square roots. The square root of 144. What multiplies to give me 144? If you have a tough time with this, think about 100. The square root of 100 is 10. It's a little bit more than 10. So 10 squared is 100. 11 squared is 121. 12 squared gives me 144, so it's going to be 12. But you could also do negative 12 times negative 12 to get you the 144. So these are the square roots of each of these numbers. If I ask you to find the principal root is going to be the positive one, okay? When we go into evaluating in the next section of your notes, we're only going to focus on using the principal roots and evaluating. We won't do both. The last one I'm doing separately because this one's a little different. When you try to find the square root of negative 25, you may be struggling with this because 5 times 5 gives me 25, and negative 5 times negative 5 gives me positive 25 again. So what is the square root of negative 25? What can be multiplied by itself to get negative 25? The answer is nothing. There is no real number anyways. No real number. We cannot take the square root of a negative number. So you may want to put the note on there. You cannot take the square root of a negative number. That's always going to equal no real number, no real solution. Down the road you may learn about imaginary numbers, which may sound weird right now, but that's what these would lead to, okay? For now, if you see the square root of a negative inside the radical, it's no real number. So Bethel Bakery made a huge square cake that was 16 feet squared in area, and Cammie needs to transport this cake to the Pittsburgh Zoo for a fundraising event tonight. Will it fit through the door that is 5 feet wide without tipping the cake sideways? we think about it, if our area is 16 feet squared and we have a square cake, then we know that these lengths are congruent or they are the same. So these lengths have the same length, which means if we find the square root of 16, we can find the side length of the side of cake. And if we know the side lengths of each side of the cake, we can figure out if it'll fit through the door. So the square root of 16 would be 4. We're just going to use the principal root for a word problem. -4 wouldn't make any sense. We can't have a negative length for a cake, right? Which means each side of the cake is 4 feet. So you guys tell me, what do you think? Will this fit through the door, or will I have to tip the cake? Nope, it'll fit. So will it fit without tipping? Yes. So where do square roots fall into the order of operations? We don't see square roots anywhere in PEMDAS, but square roots or radicals are actually grouping symbols. So write that on your notes. This is a grouping symbol, which means it's in with the parentheses and the square brackets. You can also put a square root in that category. It groups something. So you should do whatever is inside of the radical first. It's actually also an exponent. So the square root of 4, we know would be 2. That would actually be the same as 4 to the 1/2 power. You don't need to know that the square root is actually an exponent of 1/2, but what you do need to know is that you should do it first. It's in with the P's and kind of the E as well, okay? So PEMDAS, the P stands for all grouping symbols, not just parentheses. Put the square roots in there. So let's evaluate 6 and 7 together. With 6, again, I'm starting with my grouping symbol, and inside I have 49, and the square root is going to be taken first. So the square root of 49 is 7. Just use the principal root now. And when we do 7/4 minus 3/4, just subtract the numerators. You get 4/4. Don't leave your answer like that. Please don't leave it. Reduce that down. Any number divided by itself is going to be 1. What about the next one? Lots more radicals going on and parentheses. Start with the parentheses or the grouping symbols. This is the first grouping symbol I see, so I'm going to simplify what's inside of there first. 100 divided by 25 is 4, so really I'm talking about the square root of 4. I can also simplify what's in here because this is also being grouped. So within those parentheses, square roots or multiplication first? Square roots. Let's take the square roots of each one. The square root of 9 is, and the square root of 121 is, so hopefully you're doing these a little bit before me. I'm slowing down so that you can put them down on paper first. Now in this next thing, we're still with the parentheses, so we can do this first. Well, you can do this as well if you want. Remember, a grouper is in with parentheses. Technically, this is an exponent. So the square root of 4 is 2, and then we want to simplify what's inside these parentheses. 3 times 11 is 33. 2 minus 33, negative answer. If you need to make this plus a negative, go ahead and do that. But it's a negative answer, negative 31. Different signs, find the difference. I want you to try number 8. Pause the video, try it now, then press play. So for number 8, hopefully you tried it. This one had a lot going on. So you could have started in some different spots, but you should end with negative 52. So check your work. See if you didn't get that, where did you go wrong or where did you make a mistake? I started in my work. In this first line, I started with taking this first square root, and I also took this square root, and I also added these, okay? Then I multiplied these two together, and I did the parentheses over here. Within the parentheses, I did this first, the square root, and then I multiplied those. Then it's just multiplying, and then it's adding, okay? So take a look at that, correct if you need to correct. The last part of this lesson then is estimating square roots. I don't want you to get this idea that, the square root of 30 doesn't exist. It doesn't have a square root. It does. It's just not a whole number like you saw with those perfect squares. So the square root of 9 is 3. The square root of 10 exists. There's still a number for it, guys. It's just that, it's not going to be a whole number. It's going to be a little bit more than 3, but it's going to have a decimal with it, okay? And this ends up being a number that goes on forever. Let's find a way to estimate these square roots. So first thing you're going to do is you're going to identify the two closest perfect squares to your number and write their square roots. So if my square root is 30, the two closest perfect squares to your number would be 36. I'm going to do the higher below it and the lower number above it. And the lower perfect square would be 25, right? It says, and find their square roots. So these are the two closest numbers. I put the number above it, the number that would be higher below, and the number that would be lower above. Find those square roots. Your number will be in between these two whole numbers. So the square root of 25 is 5, and the square root of 36 is 6. Therefore, I know the square root of 30 is going to be 5 and something. I just have to figure out that something. Then you're going to find the difference. So I'm on the second step. Find the difference between the two closest perfect squares, and that's going to be your denominator. So you're going to make a little fraction here. The difference between these two closest perfect squares is what? How far apart are they from each other? Well, 36 minus 25 is 11. That becomes your denominator. Okay? Then you're going to count how far your number is from the smallest perfect square. So how far is your number, the 30, from the smaller perfect square? 30 minus 25, find that difference, and that's 5. That becomes your numerator. So the numerator is how far your number is from the smaller perfect square. And that means your answer is going to be somewhere around 5 and 5/11ths. You can make this a decimal, though, and you can estimate that. 5/11ths, what is that? That's about a half, right? It's really close to a half. Is it a little bit under, a little bit over? It's just a little less than half. 5.5 out of 11 would be a decimal of 0.5 or a half. So you could make this a decimal, and we could really take 5.4 or maybe even 5.5. This is just an approximation, so we should make approximate symbols because we are estimating. So we don't need to be exact, but these would be my estimates for the square root of 30. And again, we're focusing just on the principal root. Try number 7. You can try it if you want to pause and do it on your own, or you can follow along with this one for me as well. You will practice one of these on your quick checks. So again, first step is to identify the two closest perfect squares to your number and write their square roots. Now this one has a negative on the outside, so we're just going to let that tack along, okay? What would be the two closest perfect squares to 150? But it's negative on the outside, so I'm going to just put a negative on the outside of here too. Well, the lower one would be 144. And the square root of 144, the square root of 144 is 12, but I have negative square roots of 144. This is okay. You can do this because the negative's not on the inside, but it'll be negative 12. Because you have a negative on the outside, we have a negative with our answer. And the higher one, 144 is 12 squared. What's 13 squared? That's 169. So negative square roots of 169 would give me that negative 13. All right, the next step was to find the difference between the two closest perfect squares, and this becomes your denominator of your fraction. 169 minus 144, it's going to give you 25. And then find the difference between the lower perfect square and your number. 150 minus 144 is 6. I know that my number will be in between negative 12 and negative 13, so it'll be negative 12. It'll be the lower number and something. My fraction is going to be 6/25ths, and we can approximate this, guys. We're only doing an estimation, so we can approximate this. About what decimal would that be? Well, 6/25ths, that's about 1/5. And 1/5 as a decimal, you can divide those on your calculator if you have one. Or 1/5, you should know that decimal, it's going to be about 0.2. Again, we are estimating, so let's put that about symbol now. And there you go. So you're going to try this on the quick check. Hopefully you feel confident in what we had in the learning target for today.